One of the more powerful capabilities of RF Editor that would be extremely difficult to do and would require a fair amount of programming in a simple programming environment such as MATLAB is to be able to take a captured file, select very specific portions of that file that are not necessarily contiguous to each other in the capture file in the time domain, and build a new waveform that is the result of the concatenation of individually selected segments of a much longer file. We call it a stitch function. As the name implies, you're taking and selecting, first finding and then selecting segments of a particular capture file. Again, they may not necessarily and probably aren't contiguous, eliminating those portions of the file that are in between the desired segments, and then concatenating or stitching the desired segments together. A very good example of why you would want to do this is the next one, where I've captured a series of radar pulses out on a test range. So I'm going to go ahead and change my span here to bring up a different file. And I'm going to tell RF Editor to go look for the file in a new location. And as you can see, I'm just going to go ahead and point to the file location. I and Q are automatically changed to that new directory location. And when I do that, here is a radar signal that I recorded in the field. Sending that to Spectro-X and playing it, what you see is a series of different pulsed chirps, or actually radar pulses themselves, and you can see them going across the screen in the time domain, and they are different in terms of their pulse repetition interval. There appears to be at least 2, maybe 3 different radar pulse trains here, and I want to isolate one from the other. What I want is to end up with radar pulses that are 1 millisecond in a pulse repetition interval. And if I were to place markers in this file, I could see that, for example, here I only have a pulse repetition interval here of around 205 microseconds. But I may, if I select my pulses correctly, get a repetition interval here is 786 microseconds, and I know for a fact that there are some pulses here that are separated by 1,000 microseconds or 1 millisecond. The question is how to find those, how to isolate them from the other undesired pulses, and then how to stitch a new waveform that contains only those pulses. So Spectro-X, again, being very integrated with RF Editor, allows me to search for carriers and identify them in terms of their location within the capture file. Given where I am in terms of power levels here, it looks like I should be looking for the modulated portion of these pulses at somewhere around -40 to -45 dBm. I can see here in the frequency domain that I should be somewhere around that sort of power level. So let's go ahead and search for all the carriers at -45 dBm or higher. And when I do that, Spectro-X will go ahead and search for and categorize and identify those carriers for me. And I find a series of them, some of them separated. For example, these two happen to be separated by 1 millisecond, but others are not. So let's go ahead and save the search results to a file that I can use later on in RF Editor. I'm going to go ahead and save those search results, then come back to RF Editor, specify that that's the file that is the source of the desired segments that I want, institute the stitch function, and say that I want to use search results. It goes to the directory where those search results were located and pulls them up. So now what I want to do is I want to start looking for carriers that are separated by approximately 1 millisecond pulse repetition interval. So here's the first one starting at 225 microseconds, and I'm just going to go ahead and select ones that are 225 microseconds as the reference point plus 1 millisecond in pulse interval. So here's another one. Here's another one here. And you can go ahead and select these carriers specified by the pulse repetition interval that you desire to have. I'll go ahead and select just a couple more here and then create the file. I'm going to go ahead and call this PRI 1 millisecond. Give it the name. RF Editor goes and creates that file, brings it into my directory, and if I now select and send that to Spectro-X and play it, what I now find is pulses that are in fact separated based on the marker math that I'm going to be showing you here in a second, 1 millisecond, as close as I can place those markers, 987 microseconds or 1 millisecond in length.